Okie doke. Explaining constant prices. So, why don't rising prices slow the growth in resource and energy use? Well, that's easy to answer. They're not rising. Okay. Why aren't they rising? Well, we can turn that on its head and say, like, why should they rise? Okay. So, one thing to bear in mind here, and I'm going to try to remember not to leave this off, but we're talking here about what economists call real prices. Hopefully you'll remember roughly what that is. That's prices which are like, what do we call that in English? Rensade för inflation. We've like taken away the effect of inflation. So it's basically the price of energy and minerals relative to the price of the other stuff in our consumption basket. Yeah? So why would you expect energy and minerals to get more expensive compared to other stuff? It's not obvious that that should be the case, right? So you might think for any given product, if we don't know anything about it, you don't expect its price to change over time, right? So the first guess, give me any random product, my first guess is, well, its price will stay roughly the same compared to other products over time. Okay? So that's our starting point, yeah? But then you start to look at the specific properties of that product. So let's do that for resources, natural resources, non-renewable natural resources, minerals, energy. Okay, let's look at some more specifics. But before we do that, we got this question, which I'm not going to go through because it's up to you to answer. But basically, the answer should be pretty clear from what's coming later in the video. Assume two goods, A and B, that are produced by labor alone. If labor productivity in the production of good A increases faster than the corresponding productivity for good B, what happens to the price of A relative to the price of B? Okay. Hopefully you can all work that out. Okay, you might want to pause the video and think about it. Okay, because it's pretty important. Okay, but now we're going to go, instead of that sort of sorry, instead of that slightly abstract case, we're going to look at this slightly less abstract case. You might still think this is a bit abstract, but here we've got households supplying labor, some of which goes down the mine, and this is obviously some kind of a coal mine by the looks of it, and some of it goes to the manufacturing or to the main production sector of the economy, the final goods sector, we could call it. And from the mine, we get a flow of the resource. Okay, and D here is the depth. We have to go down to get the coal out. Okay, so what happens? Let's see if I'm giving you any help here. Yeah. Clearly, if the depth D increases, or if we're almost at the bottom, we're almost at the bottom and the resource is almost exhausted, you'd expect prices to go up. If the depth increases, prices go up because it's just, it's some harder work to get the coal out. If it's almost exhausted, then you expect the price to increase because that coal becomes like a scarce asset. It's like diamonds or something. It's not, diamonds are super expensive even though they're not that useful because they're so scarce. Okay. Maybe that could be the case with coal if it really was running out. But the main thing I want you to focus on is if the depth is going up, you'd expect that to put upward pressure on the price, right? Is D increasing for key resources? Think of Kiruna, think of Saudi Arabia, think of Hunter Valley. You might want to follow that link and find out where Hunter Valley is. It turns out for many key resources, iron ore, Kiruna, oil, Saudi Arabia, coal, Hunter Valley, we're still extracting the stuff we're extracting today is sort of as easily accessible as any stuff that has ever been on the earth, more or less. Okay, depth has hardly increased. Okay, so for a bunch of resources, there's hardly any increase in depth. For some others, there is some increase, which then you would expect to have an influence upwards on the price. Okay. But there's another possible influence on the price. Remember I said the initial assumption is constant. But now we're saying, what if D is going up? Well, that should push prices up, at least a bit. But there's another reason why prices might change. And that is if labor productivity of this guy, his productivity, or hers, whatever, is growing faster than the productivity of people here in the final goods sector. What will that do to price of coal? It should push the price down. Why? Okay, imagine for simplicity's sake that the productivity of people here is just staying the same. So all else equal, 10 people here with a given flow of resources will produce sort of 10 widgets per day. Okay, but the productivity of these people doubles. Okay, so productivity here stays the same. Productivity here doubled. Okay, so 10 people in the mine, instead of just producing 10 tons of coal or digging up, can dig up 20 tons of coal in a day, say. Okay, what happens to the price of coal? Well, what happens to the wage? Basically, there's a thing which in economics we call it an arbitrage condition, which means that basically if we assume that these people could equally well work here and these people could equally well work here, then wages will broadly be the same in the mine as they are in the final goods sector. And of course, if it's horrible working in the mine, you'll need to pay them a bit more. But that won't change. If their productivity here doubles, it won't double their wage relative to the people here. The relative wage will stay just enough to persuade people to go to the mine compared to working here. So the wages won't be affected, relative. So the relative wage is unchanged, but these guys have got way more efficient. These guys haven't. That is going to reduce the price of coal, right? Because the price of coal is the amount you produce. If markets are working like they should, it's the rate of production divided by the costs over that same time period. And if the wage stays more or less the same, but the rate of production has doubled, well, that is going to like halve the price of coal, right? So if productivity of these guys grows faster than average productivity here, that puts downward pressure on the price of resources. Okay, why is that interesting? Well, it turns out when we look at the data that productivity in sectors like this does tend to grow faster than productivity average in the whole economy. And the reason for that is that here we develop amazing machinery and so on, which greatly increases productivity over time. And we do that in some parts of the economy here, but in other parts of the economy, like universities or university teachers, their productivity doesn't change that much, right? So there's parts of the economy here which are very labor intensive and don't benefit that much from new technologies, where technological progress and productivity increases are slower. So when we take the average of everything here, the average growth rate of productivity here is less than it is in the mines, which tends to push the price of mined goods down over time. Okay, so we've got two forces working in opposite directions. We've got D increasing, at least for some minerals, which tends to push the price up, but we've also got increasing labor productivity faster here than here, which tends to push the price down. And in terms of resource scarcity, the fact that prices aren't going up is a strong indication that we're not about to hit the bottom here. Because if we were, then people would be like, oh wow, this is super valuable now, it's soon going to run out, we've got a problem. The prices would go up, right? Because people would be valuing those stocks of resources as an asset. The fact that we don't see that is an indication that we're not about to run out. And when we look at the Earth's crust, also we know it is a very big place. For many resources, D isn't going up. There are vast stocks of resource out there. Even when D goes up, there don't seem to be huge effects on the price. Like for copper, we know that we're extracting much sort of trickier, lower grade stocks of copper today than we were 50 or 100 years ago, but it doesn't seem to affect the price trend very much. It's a lot of different factors that are all pointing in the same direction. Don't expect resource scarcity or other factors to drive up resource prices steeply in the near future. Okay. In the slightly longer term, like 200-300 year perspective, we clearly need to drastically slow down resource extraction, or certainly we can't keep increasing resource extraction. And in the longer term, we're going to rely on recycling and so on, right? We're going to harvest energy using land, and we're going to recycle our minerals. We've dug up minerals, and then it's like, what do we use them for over time? We use and reuse. Clearly, but even that economy, then it would be like the economy with land, right? That we'd expect the price of minerals to grow at the overall growth rate, and the rate at which we use them would be staying constant. Okay, so that's some thoughts about explaining constant prices, and very, very briefly about predicting the future for resource prices. Okay, next video will be, given constant prices, why do we use more and more of the resources? And I'm going to stop this one here.